Morning everyone. So our today's lead code question is 3714, that is longest balance substring part 2. So basically it is a medium question, but honestly speaking it is a very good question. So in this question we are given a string as that consists of only three characters, either A, B or C, right? And we are given a substring is called balanced if all the distinct characters present in the substrings appear the same number of times. Suppose there is a substring a, b, c. So see, three different characters are present and all have frequency 111. So all of them have same frequency, so it is balanced, right? But suppose let's take another substring a, b, c. So now a has two frequencies, so this substring is not balanced, right? And at the end we have to return the length of the longest balanced substring present in the string s, right? Now let's say see the first example. So here we are given a, b, b, a, c, right? So if you'll see this string a, b, b, a, so a has frequency 2, b has frequency 2. So two distinct character a and b are present with equal frequency, so we get our answer as 4. Next we have a, b, this string a, b, c, c. So if you'll see this string a, b, c, all of them has frequency 1, so we get our answer as 3. So if you'll see the constraints, string length can be up to 10 ki power 5. What does that mean? Either we have to think of some solution of big of n or big of n log n, right? Our big of n square solution will not work. It will give us time limit exceed. And as contains string as contains only three characters a, b, and c. So if you'll see the brute force approach, so brute force approach is to find all the possible substrings and then check whether they are balanced or not. But finding all the possible substrings takes big of n square time, and as we have discussed, due to constraints this is not feasible. So what we have to do is we have to optimize this brute force approach to some solution that has time limit as less than n square, right? So if you'll see the what you call our substring, suppose this is I and j, some string is present here. So what are the different possible cases that makes this substring I to j as balanced? So case first, only either A, B or C has added to the substring from I to J. Suppose A, B, C, D. This is up to I. Then we add A. So see, all characters are similar only. So if one character is present, then no matter how much frequency it has, it will be balanced. So first case can be only one character is added or will be added after index I up to index j. Okay, what can be the second case? Second case is either a or b is added, a or c is added, b or c is added, and all three has added to the substring from I to j. So right, this is a case 2. What case 3 can be? Like we have added all three a, b, and c to the substring from uh, I to j. Okay, so these are the three cases that can be possible in a substring from I to j, right? So if you'll see how we'll be handling each case independently. So let's see. So first case is only one character is added, right? So that character can be either a, b, or c, right? So it will be balanced always, because if a single character is there in a substring, then that substring will be balanced. So what we can do is we can directly find the maximum consecutive runs of the same character, right? Suppose we are given a string a, b, c, a. So which one is the longest balance substring? This one, having character a with frequency 4, right? So first of all, what we'll do is to handle the case 1, that is single character as in the longest run. So what we'll do is we'll make the answer as 1, and then we'll start from the first character to the last character, and in inside we are using a while loop. What it will do is it will keep shifting the index until we are getting the same character, right? And once we get a different characters, we stop this while loop, and our answer will be maximum of answer comma the length is, suppose this is I and this is j, so length is j minus I, and then we increase our I to j, like we'll check from this index. So this is the case 1 where only single character is added after index I. Next is case 2. So in case 2, as you already seen, two characters can be added, right? So what can be those two characters? Either it can be AB, AC, or we say BC. So in this case, the count of C at index I and count of C at index j should be same. In this case, count of B at index I to index j is same if I to j substring I to j is balanced. Similarly, in this case, count of A should be same, right? Because these characters haven't been added, only either this character or this character has been added, right? So this is written similar here. Any two different characters has been added to the substring from I to j, so the count of the third will be the same. And whichever two has been added, let's suppose we have added A and B. Okay, if we have added A and B in the substring from I to j, so for it to be balanced, the number of A's added should be equal to the number of B's added, right? Here suppose, because no C is there in this string, so if it this substrings to be balanced, number of A added equal to number of B added, right? And count of C should not change. I am taking example as A and B as added and C is constant. So in this case, the number of A added is equal to number of B added, and count of C should not change. So let's make it generalize. Okay, so let's say the characters added are X and Y, and the third character is Z. Okay, so here we are again and again talking about count, and we need to find the change in the count. So isn't it pointing to prefix, right? Prefix of prefix count. So if you'll see prefix of x at index j, it denotes, so we have taken character x and y, so prefix of x, that is count of character x from 0 to j minus prefix of x, so let's say I. So how I will find the count of number of x added? Prefix at j minus prefix at I. And how will I find for y? Prefix of y at j minus prefix of y at I. So both will give us the count of x and count of y. And for the substring to be balanced, both these counts should be equal, right? So if you'll see this equation, or we can also write this equation as that. Suppose if I shift this j wala thing here, so it will become prefix of x at j minus prefix of y at j is equal to prefix of x at I and prefix of y at I index. That means whatever count of character x is present at I and whatever count of character y is present at I and j, so similarly for j. So the difference of these two characters should be equal to the difference of these two characters for this substring I to j to be balanced. Okay, so what we get the difference? So difference is equal to count at x minus y at any index, right? And count of z, can be even like x can be a, b or c, right? In that case y can be b, a, c, and z can be anything. So we are just denoting using x and y z to generalize it, right? So difference is equal to x minus y at an index, and count of z will store the count of the third character which is not added, means whose count hasn't been changed. So let's see an example to understand it more clearly. So in we are given a string a b a a c, right? So initially count of a, count of b, count of c, all three are 0 before this, right? Now at index this count of a, here count of b and a both has 1 1, count of a has become 2, count of b has 1. So see, we have stored all the counts of a, count of b and count of c. Now if you'll see from -1 to 0 and 2, -1 to 1, only two characters are added, that is a and b. No character c has been added. So isn't it the case second, that is the count of two characters has changed and the count and no third character has been added. So if you'll see the difference, 1 minus 1 is 0, and initially the difference is 0 minus 0 is 0, and count of c is 0, that is 0, and count of c here also 0. So if you'll see this difference comma count ka pair and difference comma count ka pair is repeating at index -1 and at index 1. So if you'll see AB, is it balanced? Yes, this is balanced. So if this pair difference comma count ka pair repeat for any index j to any previous index, let's say I, then the length of the balanced part is j minus I. I hope you get it. So whatever what is written here, a substring from I plus 1 to j is balanced if difference at j is equal to difference at I, difference at j is equal to difference at ai, and count of the third remaining remains same, count of the third element or third character remains the same. Okay, so what we can do is we can use a hash map that will store difference comma count as a pair, like map of pair of int comma int comma int. Okay, so what we'll do is we'll store this pair, and here we'll denote the index, first time that particular pair is pair of difference comma count is appearing, and at any index k, at any index future index k, we will check the pair in the map, and suppose if get the index I, then the length is k minus I. That means the string from I plus 1 to k is balanced. That means this string from I plus 1 to k has added only two characters x and y, and their count is same, right? So the length is k minus I. So if you'll see the code of this part, so what we do is we'll take character x, y, and z, and if you'll notice we have taken all the three cases. In the case 1, a and b are changing, and we are assuming c hasn't added. In the second case, ac is added and b hasn't changed. In third case, bc has added, a is not changing. So we have taken all the three cases, and for all the three cases we have called this helper function, right? And now see what this helper function is doing. This helper function has made a map which will in which it will store the pair of difference comma count of the third element, that is z. We are assuming that is z, x and y has been added. Okay, and this map is called as first, right? So difference is equal to 0, count of z is equal to 0, and difference initially we have 0 0 0, so difference is 0 and count is 0, so we will putting that index as -1, right? And then we will be iterating over the string, and if the element is equal to x, x can be either a, b, or c, right? In depending on the case we have called. So if it is equal to, and difference is equal to x minus y. Okay, so if s of I is equal to x, so difference will increase by 1. So difference will increase by 1 as x has increased by 1. If s of I is equal to y, if y increase by 1, then difference will decrease by 1, and else it is not either x not y, then it is z, so we'll increase the count of z. Okay, and then we'll make the pair difference comma count. We have made the pair, and then find the pair in the our map. Suppose we get some iterate auto it, so this will return as some pointer. So if this pointer is not equal to the end pointer, if this pointer is not equal to the end pointer, that means there is another pair present at some index, let's say I. Okay, some index I, which also has the same difference comma count. That means the substring from I plus 1 to the current index is balanced. So what is the length is I minus what it dot it arrow second. So basically it is an pointer, so that's why we are using arrow. So it arrow second will give us the index that is stored for this pair. Okay, previous index. So the length that we get, and then we will compare the length with the previous best. If if we don't get any previous pair with difference comma count, then we will store this pair and the index at which this pair is present, and at the end we will be returning our best, right? So let's see the case number 3. So in case number 3, what can be all the three characters A, B and C has been added in the substring from I to J. Okay, all three characters has been added, and for the substring I to J to be balanced, the number of A's added should be equal to the number of B's added should be equal to the number of C that has been added, right? So if this condition holds, then it will be balanced. That is, number of A's added is equal to number of B's added equal to number of C added. So let's see an example to explain it, to get it more clearly. So we are given a string A, B, C, C, right? Initially we have all the elements as 0, 0, 0. Okay, so if you'll see here, we also should calculate D1 and D2. Okay, so if you'll see this part ABC is the answer, right? So 2 minus 1 is 1, and 1 minus 1 is 0. Or one more thing we can do is 2 minus 1. Number of A's added is 1. Number of B's added is 1 minus 0, 1. Number of C's added is 1 minus 0, 1. So number of A added equal to number of B added equal to number of C. So this is what I have written. Prefix of A of J, let's say this is J, minus prefix of A of I, let's say this is I. Okay, this will give us the count of A, which is 1 here. Similarly for B, similarly for C. So if we'll solve these three equations, these two equation, this equation and this equation are equal. So prefix of A of J minus prefix of A of I will give us the count of A. This will give us the count of B. These are equal. So what I do is I'll accumulate what we call the J wala thing on one side. So prefix of A of J minus prefix of B of J equal to prefix of A of I minus prefix of B of I. So if you'll notice, not only this differences, not only, wait one second, not only 2 minus 1 is 1, 1 minus 0, 1. Not only these are same. If we'll do 2 minus 1 is 1. So 1 minus 0 is also 1. So this difference of the element numbers is also same. And that is what I am trying to point out here. Prefix of A at index j and prefix of B at index j, and the difference is equal to prefix of A at index I and prefix of b at index I. So this is equal. Similarly, if we'll solve for a and c, we get prefix of a at index j, prefix of c at index j, their difference is equal to difference of prefix of a at index I, prefix of a at index c. So d1, if we'll take two variable, d1 is equal to count of a minus count of b, d1 is equal to this count of a minus count of b, and d2 is count of a minus count of c. So so if two indexes i and j, I and j have same d1 comma d2 का pair, d1 comma d2 का pair, that means the substring from I plus 1 to j is balanced, because d1 denotes the difference of count of a minus count of b, that is number of a's added minus number of b's added, and d2 is number of a's added minus number of c's added. If both these are equal, then 2 into a's added is equal to b's added plus c's added, and already we have seen a's added is equal to b's added. So all three will be equal, right? a's का count is equal to b's का count equal to c's का count. This is what these things are pointing. So what will be our approach for this third case? So we'll be what we'll be doing is, uh, we'll be walking through the string, maintain counts of a, b, and c, then compute d1 and d2. d1 is equal to count of a minus count of b, and d2 is equal to count of a minus count of c, a minus b, a minus c, and show the first index where each pair appears, each pair of what, d1 comma d2. And when, if this same pair is seen again, then we will update the max length. So let me show you an example to. So we are given a string a b c c. So which string is the balanced one? So abc is the balanced one. So if you see d1 10 and 10, both are same. Okay, that means this part of the string is balanced. Isn't it balanced? Yes, it is balanced. So if you notice this, so this is our approach. Okay, let's see the code for this third part. So in this, again we have used a map to store the pair of d1 comma d1 comma d2. Okay, and we have a variable, b variable, c variable to store the counts, and initially all three are 0, so difference is d1 is equal to 0, d2 is equal to 0 at index minus 1. Iterating over the array, if we get a, increase the count of a, if we get b, increase the count of b, if we get c, increase the count of c, and then d1 is equal to b minus a, d2 is equal to c minus a, and then we'll be finding this pair in the set. if we if we get this in the map, then what we do is we'll compute the length, that is I minus it is our iterator, or we can say pointer, that's why we will be using arrow and second. So map has key and value, so it arrow first will give us the key, it arrow second will give us the value, that is the index of the this previous pair where it was seen earlier, and then we'll update our answer. If it is not seen earlier, then we'll be pushing this pair in the map, right? And one more important thing is that normally we don't have a map of pair of int comma int. Okay, so for making this, we have constructed a struct of pair hash. Okay, and if you have noticed, every time we have called the our function, or we have defined our map, we have used this pair hash struct. Okay, so what we are doing is, how we are storing is, so suppose in pair we have a and b. So what we are doing is we are taking a 64-bit number, a number, each number here can be up to 32 bit, and then we have shifted our a to 32 bits. Okay, so first 32 bits is a, and then second 32 bits is b. So here our map is, instead of storing a pair a b, it is storing a number, this a and b of 64 bits. So basically this is a jugaad. Okay, so I hope I am able to explain you the whole process. So if you like the video, please make sure to like, share and subscribe the channel. Thank you.